Well, ladies and gentlemen, good afternoon and welcome to the gym service room here at Actu AGL House for the Energy Saving Workshop. I'm Cam Sullings from Actu AGL. I work in the events and sponsorship team, so not only have I played a small role in helping to organise these events that we started last Tuesday night, but I've also been thrown the ball to get up and present and welcome you and introduce our speaker this afternoon. Personally, I found the workshops to be very, very interesting and beneficial as well. And some of the things that Matt will talk about we've employed at my home, but there were some other ones as well. So, and I'm sure that could be the case with you as well. So you will find the next hour or so to be very, very interesting. Most of you, I can see, do have your packs and registered on the way in. Thanks for doing that. There's pens, tip sheet, and room for taking notes as well as you go along. There's the tips brochure for energy saving, payment options brochure. There's all sorts of brochures and information in there. So we would ask that you take some time just to have a look through those. We have the Lucky Door prize as well, and it is the energy saving kit valued at just under $100. So at the end of our workshop this afternoon, we'll do a draw and someone will walk away with an energy saving kit. We also have a small and very brief survey that we'll ask you to do at the conclusion of the event as well. It's been our experience, and this is the 5th workshop that we've run, that there is a lot to jam into in the next 60 minutes or so. So we may run a little over, maybe 10 or 15 minutes over, but if you need to go, obviously it's lunchtime today, so just feel free to wander out. I don't think Matt's going to take too much offence. You can see the cameras here as well today. We're just shooting this event for the Actu AGL website. There'll be no one featured, so don't think we're going to point a camera in your face and you'll be asked to speak or anything like that. If you don't turn around, you won't be on the telly. Pretty much simple as that. Going to introduce now Matthew Ruffin, our speaker. Up until the program's closure, Matthew worked at the Home Energy Advice Team, or HEAT, which was funded by the ACT government, providing free, independent expert advice to individuals on how to improve the energy efficiency of their homes in Canberra. He audited well over 1,000 homes here in the nation's capital, so he's well across his stuff. He is scientifically trained, he has a couple of degrees and lots of on-the-ground experience as well. He's a passionate proponent of sustainability. He studies and educates on the issue, but also practices what he preaches. And I've seen him speak a couple of times now, and he's referred to himself as an energy geek, so affectionately that's what we've known as here this afternoon, and you'll be soaked up by his enthusiasm and passion as well. He's an expert on practical energy saving solutions for people to adopt in both home but also behavioural patterns as well. And those are the patterns that we need to see make a difference and take a little bit off your energy bill. So enjoy the next hour, I'm sure you will, and let's welcome Matthew Ruffin. Thanks, Matt.
Good afternoon, everyone. My name's Matt Ruffin and I'm from Progressive Sustainability. There's my website up there. We've got a lot to get through, so I think I'll get straight into the energy saving tips. But first, actually, I will mention basically everything that's on the slides is in this tip sheet here. I've put it in shorthand. Hopefully you'll be able to use it at a later time to trigger your memory about certain things, and certainly scribble all over it, circle things, take notes, etc. But it's all on that 3-page tip sheet there that you should have from your packs. I've broken the workshop down into 3 sections. The first section is called Improving the Home Envelope. That's actually improving the building you live in. And unfortunately in Australia, we tend to build very leaky houses and we tend to under-insulate, so we lose a lot of heat. We do what's called heating the neighbourhood. So I'll talk about that for a while. Secondly, I'll talk about heating, cooling and hot water heating, just a tiny bit on cooling. We're going to concentrate on heating and hot water heating because those are your major energy users. And then finally at the end, we'll wrap up everything else, things like lighting, cooking, washing, etc. But let's get straight into it. Improving the home envelope. Now, what is this home envelope I'm talking about? Well, the home envelope is basically everything from the ceiling down, from the walls and windows in, and from the floor up. So I don't want you to be thinking about your ceiling cavity. That's not a place you really want to be insulating. You want to be insulating the area you live in, and that's the home envelope. You want to seal that up so that air can't move in and out of the envelope, and you also want to heavily insulate it. And I'll talk about both of those things. That will help you in both summer and winter, although winter is where we're trying to get the most benefit. There are 3 important things you can do to improve the home envelope. The first of those is to seal it. That is to stop air leaking in and out. The second thing you can do is bulk insulate it. Now I use this word bulk. There are 2 types of insulation. I'll explain that later on. But just think of bulk insulation is those bats or loose fill that you would have seen, you'd be very familiar with. And third, window coverings. Windows are very important. Windows lose a lot of energy and they also create currents which move air around and make you feel less comfortable. So I'm going to talk about all 3 of those things. But let's start with air leaks and sealing up the home envelope. Unfortunately, Australian homes tend to be riddled with holes. In other countries like Canada, Europe, parts of North America where it's really cold, they actually require that you wrap the home in plastic, put a blower door on the front door, increase the pressure in the home, and find out where the leaks are and seal them up before you even sell a house. But in this country, we don't do that because we do have a milder climate. That results in leaky homes. Not only does a leaky home mean that you directly lose hot air to the outside, or in summer, gain hot air inside, it also can create a draft. Now, drafts can cool you down by up to 4 degrees. So you could be sitting in a room that's 18 degrees, which is quite a comfortable temperature, but it could feel like 14 if there's a lot of air moving around because of drafts. So sealing up the house has 2 benefits. Keeps the heat in, stops the drafts. And this is the cheapest and most effective way to make you feel more comfortable and to use less energy. So how do you find leaks? Well, I've got a really simple trick for you. It doesn't cost you anything. On a windy day, it's going to work best on a windy day because then the air is going to be forced through the cracks. Close up the entire house. Close up all your doors and windows. Turn off your heaters. Make sure your exhaust fans are off. And then get a piece of incense. And you want to stand in different places all over your home, in front of your front door or your back door, up high and down low, in the corner of rooms, in front of windows, in the middle of the room. You just want to stand there for 30 seconds. And if you see a stream of smoke coming off the incense consistently in one direction, then that's telling you the air is coming from the other direction. So use the incense to track back to where the air is coming from and then seal it up. So remember the incense test. The other thing I want to mention at this point, I'm just about to go through a bunch of different leaky parts of our home, but you can be creative. So I'm going to give you some solutions, but it doesn't matter. All you're trying to do is seal up the leak. If you find a way that's different from the way I described, that's fine. It's a creative exercise, sealing up your house, unfortunately. There's no orthodoxy to it. So I won't read through this list because we're going to go through all these with pictures. But these are major sources of leaks. Things like downlights and gaps and cracks around skirting boards, evaporative cooling vents, etc. But we'll go through these with pictures so I can illustrate it a bit better. Now the first thing I want to explain is downlights and recessed lights. Now we don't have any downlights in this room, but downlights are these are sort of downlights. These are downlights that you can point in any direction, but most downlights are just flush with the ceiling. Recessed lights are lights that go up into the ceiling like this. They're a sort of a dome, and you can generally put an old school 240 volt globe up into the dome. So what do we want to do with these? Well, these actually, downlights don't seal very well, so they'll often act like chimneys and actively suck warm air out of your house. But if we put a downlight cover, a proper downlight cover on the downlight, not only does it seal the downlight, but it also means that you can insulate right up to the sides of the cover. Now, there's only one type of cover that I recommend because there's only one cover on the Australian market that you can insulate up to the sides of. All other covers, you have to still leave a big gap around the downlight, and that's no good for your insulation. So this is called a 10-mat cover. I will actually write that one up, T-E-N-M-A-T. They're not expensive, about $15 each, and if you buy in bulk, I think you might get a discount. 10-mat covers, they're from downlightcovers.com.au. You can't really miss that one. The way these work, this is an example of a 10-mat cover over a simple regular downlight. The way they work is, well, you actually silicone seal it to the actual ceiling, and then you can insulate right up to the side of it. The cover itself is rock wool. It's fire retardant to 1,000 degrees. And as I say, the great benefit is you can insulate up to the sides and over the top of those covers, which you can't do with any other cover. I would make one other recommendation with downlights though. If you have halogen downlights, those are the old school ones, they blow a lot, they're very hot. If you don't know what you've got, touch it, put your hand near it. Don't actually touch it because you'll burn yourself. But if it's really hot, that's a halogen downlight. That's using a lot of energy. I would actually replace them with LEDs at this point. LEDs use virtually no energy. They produce virtually no heat, so they're not a fire hazard, and they will last 40 to 50 times longer than a halogen. In other words, you put them in, and unless you get the 1 in 100 that's a dud, it'll last for 20 years. Well, I can't guarantee you 20 years, but it'll last you a hell of a long time. So that's classic downlights. Now with recessed lights, much the same thing. You just need a bigger cover because, of course, the recessed light goes up into the ceiling like this, so you need a bigger cover to put over it. But once again, you can just insulate right up to the sides of it, and voila, you've solved the issue. Let's move on to exhaust fans. Here's a classic exhaust fan. This is basically a hole in your ceiling. So any warm air in the room with the exhaust fan will just be going straight up the exhaust fan, even if the fan isn't on. It's still a hole in your ceiling. This is what we call a draft stopper, as I've put here, draftstopper.com.au. This simply gets put over the exhaust fan. These flaps will close when the fan's not on, and they open up when the fan is on. Now that stops the exhaust fan acting like a chimney, and then once again with your insulation, you can insulate right up to the sides of it. So the draft stopper is a great thing to use with an exhaust fan. The other thing I want to mention though, most of you will probably have a tastic in your bathroom. Does everyone know what a tastic is? Yes, with the heating elements, heating lamps. Right, so I would not put one of these over a tastic. The reason being, if someone accidentally leaves the heating elements on, the heat will build up under the cover and could be a fire hazard. And that's the last thing we want. What I would do instead with tastics is either, very simply, keep that door shut and draft seal that door. It'll just be a bathroom door. So draft seal it as best you can and try to stop any heat from your house getting into your bathroom. The second thing you can do though, especially if it's an old tastic and maybe it's broken or one of the lights isn't working, it needs replacement anyway, get yourself an eco-tastic. They have a built-in one of these and also a temperature sensor that automatically turns the tastic off if it gets too hot. So that reduces fire hazard, and also you get one of these built into it. They're a little bit more expensive than a standard tastic, but yes, I would replace with an eco-tastic if you're concerned about that. Moving on, next I want to talk about doors. So doors can be very leaky if you haven't draft sealed them. These pictures are a little difficult to show, but after the presentation, if you'd like to, I've got some what we call draft sealing tape up here that you can come and have a look of and a touch of. Draft sealing tape is stuff that you put around door frames to seal the gap between the door and the door frame. It comes in rubber and hardened foam. It even comes in brush. It's very cheap. It's easy to put on, and sometimes it comes in big reels and you can take off 10 metres and just cut it and take it to the front of the hardware store, or often it comes in a box like this and it has instructions on the back. Actually, the other thing I want to mention at this point is if you're ever worried about doing any of this stuff, YouTube is your best friend. Put the keywords into YouTube and there'll be 100 people across the world who will have a little video there showing you how to do it. And this, Green It Yourself, is a local person showing you how to do these things. Did anyone see Carbon Cops a few years ago? Lish from Carbon Cops has done greenityourself.com. It's a series of videos telling you how to do things like seal doors. So don't be afraid of doing this stuff yourself. It's actually, a lot of it's quite easy. You just got to follow the instructions, look at a few videos, do it once, and you'll be confident you'll be fine after that. So with draft sealing tape, these are pictures of my front door. This brown stuff that you can probably just see here, that's the draft sealing tape. It's on the frame of the door closes against it, air then can't get through. Before that I had about a 3 or 4 millimetre gap there. Here's a picture, you put it on the door jamb so that it doesn't get in the way of the door shutting. If anyone's worried about that, I can show you after the presentation. And here's my bathroom door. I've put a different type of draft sealing tape. You can see it's white and it's thinner because I had a thinner gap. So you really got to just go around your house, work out how big the gaps are, buy a bunch of draft sealing tape, go home and stick it on. Now the bottom of doors can also be very leaky. So there are a lot of different what we call draft excluders or bottom door seals, and here's a couple of them. There's one there and one here. This is a spring-loaded one. The reason it's spring-loaded is because often on front doors you have a piece of metal across the front door. So it needs to spring up when you open the door to get over the piece of metal. These are about $25 at any hardware store. And as long as you always measure 3 times, cut once, that's the goal, that's the thing to do whenever you're doing DIY stuff. Measure thrice, cut once. As long as you do that, they're not that hard to install actually. So that's a bottom door seal. This is what I call an automatic snake. It sort of looks like a paint roller. But the beauty of this, the reason I call it an automatic snake, is it stays with the door. You know, if let's say you're using a snake at your front door to seal your front door, if you go out of your front door, the snake is then sitting well away from the door and you've got a gap under the door. But with this thing, there's a couple of hooks and it simply bolts onto the door and it stays with the door and it rolls. It's a paint roller type thing, so it rolls with the door when you open and close it. These are about $20 at whatever used to be Magnet Mart. So if you can't find things at Bunnings, go to Magnet Mart or another hardware store. They actually quite often have quite different ranges of this stuff. They'll all have draft sealing tape and they'll all have these things, but often they won't have the more exotic things like this. So that's doors. And I've sealed my front door and my bathroom door because I used to get a gale going under the front of my door and going through to my bathroom door. But I've eliminated that now and that's made the living room a lot more comfortable. Next, cracks. Gaps and cracks, you can find them all over your house. So here's a picture of a skirting board crack. Sealing something like that up, well, usually you'd use a silicon sealant or a caulking gun. You can actually get water-based caulking as well. But that gap looks a bit big for a caulking gun, so you might use something like this. This is called a foam core rod. You can get this at any hardware store. Once again, you can come up and have a play with it if you like, but you just compress it and push it into that gap and voila, you've sealed the gap. Very cheap again too. There's cornice cracks, architrave cracks. The architrave is the frame around here, not the actual window frame itself, which is that, but the architrave out here. These sort of things often have cracks that are small enough that you can just use a caulking gun and simply seal it. You can get different, you can get clear caulking, you can get white caulking, you can get different coloured caulking as well. And then this picture, it doesn't come out very well, but there's actually a gap between the black rubber seal here and the actual window itself. It's come out of the seal. You could actually take the window apart and put it back together, but if you're not confident to do that, once again, you just use a caulking gun there to seal that gap. Now, these things are called passive vents. Has everyone seen those? You got any of those in your house? Yeah, okay. This is the old school passive vents, often found in walls. This is the ones found in houses built in the late 70s through to the early 90s. Passive vents don't actually do anything for you. You're not going to suffocate if you get rid of your passive vents. We don't put them in new houses, haven't done so for 20 years. So you don't need them. You can rip them out and replaster and paint there. Or if you want a really simple, cheap way to make sure they're not letting any air through, simply get some contact, some plastic contact like you'd put on a school book. And so you just cut a piece of contact to that size, stick it down on there, and voila, you've stopped any air moving through it. Down here we have a typical evaporative cooler vent. Even when you close the vents like this, still a lot of air gets through them. And the machine itself is meant to seal, but often they don't seal particularly well. So what I would recommend is an Australian invention called a heat saver cover. Heatsaver.com.au, I think it is. They use magnets that you just attach around the frame here, very easy to do yourself, and then this cover goes over the top and voila, no air can get through there. They're not expensive. We're talking, depending on the size of the vent, something like $20 to $40, I think. Just have a look at their website. Once again, I guess you could just put clear contact over that and then rip it off when summer comes along too. That's another way to do it. And finally, there's things like permanent openings in toilets. Here's a permanent opening up here. You could get a piece of balsa wood or plywood or cardboard, or this is actually called core flute board, this stuff here. This is really useful stuff. It's cheap, it's light, it's easy to cut with a Stanley knife. You could cut a piece of this, get some double-sided sticky tape and stick it up there. Or the other thing I should mention at this point, which comes in handy later on too with window coverings, is Velcro. There's a whole range of self-adhesive Velcro products that are fantastic. You simply peel this off and you can stick one side of the Velcro onto just about anything, onto fabric, onto brick, onto plastic, onto wood. You just stick it down, come back an hour later, and it's like rock. You can get this at any sewing shop, some hardware stores. Really useful stuff, Velcro. So you could put Velcro here And then make yourself a little cover and stick it on and take it off anytime you want too, if you want something that's removable. Don't forget the Velcro, the range of Velcro products out there, because they're really good now. So that's some examples of sealing your house up. Those are the major places that you'll need to seal. But as I say, test for yourself and see what you find. Now let's move on to the second part, which is bulk insulation. Now, I said there are two types of insulation. I'll just mention very briefly the other type of insulation, which is called reflective insulation, also called sarking, ciselation, or foil. It looks like aluminium foil, and it's not going to help you really in winter. So we can sort of ignore that, push that to the side. What I want to talk about is bulk insulation. That is pink bats. They're not all pink. Some of them are orange. They come in grey, etc. as well, but bats or loose fill. Now, how does bulk insulation work? Well, heat actually conducts through your building, and this is how you lose most of your heat in winter. Heat goes through the walls, well, through the ceiling first, through the walls and windows, and through the floor to a lesser extent. It actually goes through the materials. The way in which we slow this down is by trapping small pockets of air. That's what bats do. The bat material actually doesn't do much, but the little pockets of air trapped within the bat is what insulates. Unmoving air is a really good insulator. Also think of double glazing. Same thing, you're trapping a pocket of air or a vacuum or a layer of argon. Think multi-layered window coverings like multi-layered curtains. Once again, 2 layers of curtain, trapping a pocket of air in between. It's the air that's doing most of the insulating. The other thing I should mention is the greater the temperature difference between, say, inside and outside, the quicker heat will conduct. So in winter, it could be, let's say it's 19 degrees in your living room, it's -3 outside. That's a temperature difference of 22 degrees. So that means there's a lot of force behind that energy moving out of your house. And this is why we need to insulate. Insulation will also help you in summer, but it'll help you most in winter. I've already mentioned that it's all about trapping small pockets of unmoving air, and down here we've got some nice pictures. This is some really well laid insulation bats. You can see they're well laid because there aren't gaps. So gaps vastly reduce the effectiveness of insulation. You want as much coverage over your ceiling as close together as possible as you can do, or as the professionals can do. They should be doing it like that. This is some loose fill cellulose. Loose fill is fine as well, although as you can see it does make it a bit more difficult to get back in the roof space and do anything if you need to, because you can't see where the joists are to walk on. Now, we measure the effectiveness of insulation in what are called, or bulk insulation, in what are called R values. R stands for resistance to conducted heat flow. So just remember, R for resistance, that tells us the higher the number, the better. Have you all heard R2 this and R4 that, R1.5 that? Right, okay, that's what that's talking about. And actually everything around us has an R value. It just tells us how much resistance there is to heat conducting through it. A rough rule of thumb for standard bulk insulation materials is R1 is about 5 centimetres. So R1's about that, R2's about 10 centimetres. A lot of Canberra houses have R2 or R1. R2 will just about come up to the ceiling joists. R3's about that, R4's about that, and R5's about that. Now in this climate, you want at least R4. The standard is actually now R5, but the reason I say at least R4 is if you've got R4, that's doing most of the job of R5. So I wouldn't be spending a lot of money on just upgrading from R4 to R5. If you've got R4 or more, you can leave it, but if you've got less than that, I would be adding insulation to your ceiling. You'd always insulate the ceiling first. The ceiling is the place you lose the most conducted heat. Secondly, you do the walls. And I should mention how they do the walls. In a new house, obviously, it's easy. You just put the insulation into the framing as you're doing it. But in an older house, what they do in most houses, they get onto the roof, pull up roof tiles, put a pipe down through the cavity in the wall, and then blow in a substance called rock wool, loose fill rock wool. And that progressively fills the wall up, and adds about R3 to the wall. So it does very well. If you get your walls over R2, you're doing well. So you always do the ceiling first, then the walls. Floors I've put in brackets because I really wouldn't bother insulating your floors at that point. I would do the ceiling, the walls, and then the window coverings, do your gap and crack ceiling, see how you feel. I would bet in most houses that you don't need anything more, so I wouldn't be going to the expense and trouble of then insulating your floors. There is an exception. If you live on the side of a hill, here's your floor, here's the hill. what you'll often find is there's too much air moving underneath the floor, and that can draw heat out of the floor and make it feel very, very cold. In that case, if your floors are freezing, that's when you might want to insulate your floor to stop your floor feeling freezing all the time. But I would still do ceiling walls first, and then in that special instance, I'd think about doing the floor. As I said, gaps in insulation reduce its effectiveness, so try and avoid gaps. And that's why those things like the downlight covers and the draft stoppers are really good. I want to also mention one other thing with your insulation, and that's skylights. So a skylight like this is basically a big hole in your ceiling insulation. Even if it's double glazed at the top of the skylight, that's not going to help you that much. What you can do though is you can really cheaply insulate this and still get light out of it. So this bit at the bottom is called the diffuser. You simply take the diffuser out, which you often have to do to clean it anyway, and then you get bubble wrap. And you want layer, remember I talked about trapping small pockets of air? Well, bubble wrap's a really good insulator because it traps small pockets of air. So you then just put layer after layer of bubble wrap on top of your diffuser until it's at least 20 centimetres thick, roughly the same as your ceiling insulation. That's about R4 ceiling insulation. You could go more, you could go up to 25 centimetres, that would be fine too. It just depends how much bubble wrap you can get and how committed to it you are. But yes, so just layering bubble wrap on top of it, you'll still get light through the skylight because it's bubble wrap and light will pass through it, but you've then insulated your skylight much the same as the rest of your ceiling. Okay, so that's insulating. Now we'll move on to window coverings. This is slowing down the heat loss through your windows. So windows, the first thing you should know about windows is that they have very low R values. I talked before about your walls, you want them at least R2, your ceiling you want R5. The R value of your average single glazed aluminium framed window is 0.15. That just tells us that heat moves through it really, really quickly. And if you want to confirm this for yourself, tonight when you get home, touch your window, you'll feel how cold it is. That's telling you that it's just sucking heat out of your house. Now, there are two ways to slow down heat loss through windows. The first is insulating window coverings that are sealed to the wall or the architrave around them. And the second is double or triple glazing. And I'll go through both. We'll start with window coverings though. Now, a window covering needs to do two things to help you properly. And the first is it needs layers which trap static pockets of air. I've talked about that enough. The second thing you want to do though is seal the window covering to the wall or the architrave around the window. You don't want the cold air in the window space getting out into the room because that creates what's called a convection current. I'll illustrate it here. We've got our cold window here. The air next to the window cools down, so cool air falls. That falls off the window and along the floor, making your feet feel cold to start with. That will create a partial vacuum in this space. Warm air gets dragged down into the window space, cooled down by the window and flushed out. And so you get this circular convection current that cools the room down. It not only means you're losing heat through the window, it also is creating a draft that is making you feel colder. So that's why it's really important to seal your window covering around the window. Now, the first type of window covering I'd recommend is a multi-layered curtain. Here I have a picture of what I'd call a multi-layered curtain. We've got our aesthetic frontage here, we've got a block-out backing, and they're sewn together at the top. That then creates, so you've got your two layers, that creates an air pocket. The air pocket will do some insulating. But I'm going to tell you how to make a superb curtain that you'd find in a place like Canada or Europe. And the way you do that, it's very simple. You put some of this stuff or this stuff in the middle of those two layers. This is called wadding. This is what we put into quilts and doonas. It's basically a thin insulation bat, as you can see. This one's about a centimetre thick. You can get it in 10 millimetres or 20 millimetres. If you can get 20 millimetres of this stuff, sew it into the middle of these two layers here, you've basically put a thin insulation bat on your window and that will do a superb job of insulating. I've actually done it at my own home. It's made a superb difference. If you don't want to use wadding, you could use 4 or 5 layers of bubble wrap instead in between the two layers. Same thing, you'd sew them into the top here. I like the idea of the wadding though, and you can get that at any sewing shop, and once again, it's cheap. If you know anyone who's good with a sewing machine, you can make your own curtains very cheaply, and they'll be extremely effective. They'll be as effective as anything that you can buy. So that's the curtain itself. The other thing we need to do with the curtain though is seal it in all directions. So you need some sort of pelmet. This is a picture of what I call a box pelmet. I'll illustrate it here. Here's our wall. Well, actually, no. Here's our window reveal. So this is the window here. Here's our curtain railing here. Now what a box pelmet does is comes out and down like that. And in that way it stops the warm air being sucked in from near the ceiling space. So you can buy these, you can build them yourselves. It's really easy to build one. A lot of people don't like the way they look. So I've come up with something else that you can do if you don't want to put a box pelmet on. And that's what I call a blind pelmet. Now, for a blind pelmet you could use, once again, balsa wood, plywood, or I think actually this stuff would be perfect, core flute board. Once again, perfect. You cut a piece of that, that's the thickness of the wall to the runner. Just sealing that sort of gap there, and then simply stick it down on the brackets that are holding the runner to the wall with something like double-sided sticky tape. As long as it's sealing all the way along the top of your curtain, no one will ever see it, but it will be stopping that air being dragged down into the window space, and voila, you've got a blind pelmet because no one can see it. So that's something you can make very cheaply and easily for yourself. Now the next thing that I'd recommend with the curtain is often, because the curtain's sitting away from the wall, there'll be gaps at the side of the curtain, between the curtain and the wall. They're really simple to seal. Once again, you just use a Velcro product. Get some Velcro, put it on the wall or the architrave and on the curtain, and actually stick the curtain down to the wall. No one will ever see it. The final thing you want with the curtain is you want it just touching the floor, and that way cold air can't be travelling underneath it. So if you do all of that, you will end up with a superb insulating curtain. The cold air created by the window gets trapped in the window space, and any heat that wants to leave the room has to go through your multi-layered insulated curtain. Voila, that will do a fantastic job for you. The next option is a honeycomb or cellular blind. Now honeycomb, I think in Britain they call them honeycombs, in America they call them cellulars. It's the same thing. What it is basically double glazing with fabric. If you see this picture here, this is 2 layers of fabric, and in between is a layer of trapped air. Now you can buy these, there's a wide range of these things on the market. Go to some curtain shops and have a look. The reason I've put a big tick here and a big cross here is that these things must be installed inside this space here. This space is called the window reveal. You've got to install it inside the reveal. If you install it outside the reveal, the air is just going to pass around it and it's going to be a lot less effective. So as you can see, this is an excellent installation. These things are installed inside the reveal. They're very close to the sides of the reveal, and that will do a great job insulating that window when it's down. Over here, this one's not inside a reveal, so the cold air from the window space can simply pass around it. So I would always put them inside a reveal. Some windows won't be suitable for them because you won't have a reveal. Roman and Holland blinds are generally just a thin piece of... Romans are the roll-up ones. Sorry, Hollands are the roll-up ones. Romans are the ones that pleat upwards like this. They're generally just a thin piece of plastic or fabric. So they'll insulate a little bit, but not really that much. If they're sitting outside of the window reveal, you could stick them down at the sides and the bottom, and that's the best thing you could do to improve them. At least try and trap that cold air in the window space. Unfortunately, things like Venetian and vertical blinds are not going to help you with insulation. There's too many gaps in them, and once again, they're a thin piece of plastic, metal or wood. So they're not an insulating material. Their Venetians or verticals are really only good for privacy. They don't do much else for you. So that's window coverings. Now double glazing. Double glazing, as I said, is very simply 2 panes of glass trapping a pocket of air. You can now actually get triple glazing in Australia, and in Europe you can get quadruple glazing. What double glazing does is basically double the R value of single glazing. So it's still a low R value, but that tells us that half as much heat will be passing through the window as was for the single glazing. It is expensive, but the price has definitely come down a lot. And you can use it tactically. What I mean by that is you don't have to double glaze your whole house. So you don't have to look at your house and say, oh, I've got to spend $25,000 insulating every window in the house. If you only heat your living room, maybe, and your kitchen, let's say, maybe you could just double glaze your kitchen and living room windows, vastly reducing the cost. And maybe you just do it one window at a time. You do one this year, one next year, and one the year after. It's better to do them all at once, but if you don't have the finances, then yeah, think very carefully about how you can use it. You don't have to do it all at once. You don't have to do the whole house. A couple of things about double glazing that are important. The width of the gap is important. It should be 12 to 16 millimetres. And most double glazing has this, but I have seen a lot of 6mm double glazing sold as well, and it's just not that effective, so I wouldn't be paying for that. And the second thing is that the framing is very important. So what you want is timber framing, that's great. UPVC framing, that's just a plastic, but that's fine, frame it with that. Or thermally broken aluminium. That's aluminium inside and outside and an insulator in the middle. The reason for this is that aluminium is the second best conductor of heat on the planet. So if you have just an aluminium frame on a double glazed window, you reduce its effectiveness by about 40%. You've spent all this money on a window and then take off 40% of the effectiveness of it. So you have to pay a little extra for good framing, but get the right framing. It's worth it. It's a long-term investment. The other thing I'll mention is if you have existing timber framed windows, you may be able to just take the single glazing out and put in double glazing. Now this can be half the price because half the price of a window is its framing. So if you already have timber, you might find that actually putting double glazing in is a lot cheaper than you expect. And I guess the other thing I should mention at this point is get at least 3 quotes. I'd be getting 5 though. And I do the same with any of this sort of work. It's just that I've seen vastly different quotes from different companies. So do your research, you know, take your time. You're going to be spending a fair bit of money if you do something like that. Get a bunch of quotes. Go with who you trust the most and who the best quote is. Finally, just before we have a little break and some questions, I'll just mention for summer, I know that that's the last thing we're thinking about right now, but in summer I want you to remember a very simple rule of thumb. Drawing your curtains in summer is not going to help you much. It'll help you a tiny bit, but not much. What does help you a lot in summer is shading windows before sunlight actually hits them or comes through them. So very simple rule of thumb for you. You need external window coverings for summer and internal window coverings for winter. External for summer, internal for winter. Lock that one in your brain. The reason for this, I'll give you the little technical reason. The reason is the sun beams out what's called shortwave infrared or shortwave heat. If you ever heard the term infrared, it just means heat. Shortwave can pass in through glass. It hits things in the house, whether it be this guy here or the floor or the furnishings. It's absorbed by them and immediately re-radiated, but as a different type of heat called long-wave heat. Long-wave heat cannot pass through glass. So effectively, the heat in the sunlight is trapped in the house once it's come through the glass. And that's why drawing your curtains won't help much. Your curtains will just warm up, and then that heat's trapped in the house. So yeah, external shading's the way to go. What am I talking about? Things like retractable awnings, verandas or pergolas, although don't put them on the north side of your house because you get a lot of sunlight in winter from the north side of your house. You want something retractable if you're going to put it on the north side. You can use vegetation. You can use shade cloth or shade sails. There's a product called Wren Shade. Look that one up. I've put it on your tip sheet. That's an easy and cheap one to apply. Doesn't matter how you're doing it. Stop the sunlight coming in through your windows and your house will be a lot cooler in summer, especially if you've sealed it and insulated it properly. You'll find on most days you'll be very comfortable. Now, we'll just have a quick short question time. Has anyone got any questions at this stage? Yes?
Building a house at the moment, and we've been told to use something called Viridian glass, which is sort of supposed to be similar to double glazing. What's your...
Viridian, that's probably low E or low emissivity glass.
It's apparently got a...
It's got a coating on it?
Well, it's got a thin layer of aluminium or something.
I think it's iron oxide, actually. Yeah. Look, I'm not sure, but I think it's called... there's another manufacturer called Pilkington. They manufacture something called comfort glass. Yes, it's a layer of iron oxide on the inside of the glass and it reflects some of the heat back into the house. It's better than single glazing. It's not quite as good as double glazing. Some double glazed units are both double glazed and have the low emissivity coating on it. Now, yes, it will help. It's better than single glazing. It depends on price, I guess, at that point, and that's the sort of decision that you have to make. But if you'd like to talk about it more afterwards, please come and have a chat with me. Anyone else like to ask it? Yes, sir.
We've got a house on the side of a hill.
Oh, yes.
So for underfloor insulation, is it the same as the ceiling?
The same stuff. You can actually get Polystyrene, okay, everyone knows what polystyrene is, that white plastic. That traps little pockets of air in it. That's actually a really good insulator. You can get polystyrene block and clip lock systems from hardware stores as well. So you could either use polystyrene or you could use, I'd put an R3 bat. I mean, the difference in price between an R2 and an R3 is virtually nothing. So you just put R3 bats underneath the floor and then either, well, the best way to do it is a fine mesh running all the way under the floor and up the sides. And the reason for this is that things like to nest in it because it's warm. So, and strangely enough, things like possums and rats love to eat it too. So it's a bit strange. But yeah, you can go with one or the other system. And also, by the way, there's a lot of information on the internet in this stuff, on this stuff. So you could always just put floor insulation systems into Google and have a read. Maybe one more question? Yes, sir?
About the double glazed windows, I'm also building a house and I'm going with a double glazed window, which is 4 millimeter sheets of glass with
4 millimeter and 10 millimeter gap.
Then 4 millimeter. Is that good or?
It would look a little bit more of a gap would be better. As I said, 12 to 16 mils is ideal. 10 is not bad. It would just be better if it was a little wider. Maybe, yes, and then we'll go on. Yep.
For windows that are single glazed, there's a product on the market, I don't recall the name.
Clear Comfort? Yes.
Something like a contact on
yes,
you can see through
it's called Clear
slightly.
Comfort.
If anyone wants to have a look at that one. Yes and no. Applied properly, it can do a bit for you, but it only really works on timber-framed windows. It won't work on standard aluminium and sliding windows. If you slide the standard aluminium window, you'll rip the Clear Comfort. But yeah, if you've got timber-framed windows, you could try it. It's not expensive, worth a go. All it's doing is trapping a pocket of air between the plastic and the glass. It's not as good as double glazing, but it will do some of the work.
Maybe
I think
half
it
or
sort of
10
goes on like contact by the looks of it.
No, you actually stick it to the frame, this one.
Oh, the one I've seen looks like contact. You literally stick it on the window.
Yeah, I can't see how that's going to help, actually. Yeah. I think what you're talking about, though, is Clear Comfort. Okay, so I'll be around at the end to answer any further questions, so don't feel like you can't have your question answered, but we better keep moving because time is not on our side. So I'll move on to heating, cooling and hot water heating. Now, this is one to take away, to tell all your friends, to tell everyone you know, 60% or more of the average total annual energy bill for a household in Canberra is heating. So we can make changes elsewhere with appliances and other things, and they will save you a bit of energy. But the big ticket item for saving energy is heating. It's by far the biggest energy user in Canberra households. And there are two factors that influence your heating bill. The first is technology. By that I mean the technology of the building. Have you sealed and insulated it? We've said enough about that. And also the technology of the heater. How old is it? Is it functioning properly? Has it been maintained properly? All that sort of stuff. And then secondly, behaviour, and I will come to behaviour in a moment. But first we'll talk about different types of heaters and efficiencies. So as I said, the first priority is to keep the heat in. That's why I spend the first half of this workshop talking about things like sealing and insulation. If you're purchasing a heater or replacing a heater, a couple of things to think about. How do you use the heating? In other words, do you really need central heating, or could you just do with what we call a room or space heater? That's a heater dedicated to one room, possibly two if you can get one that ducts in two directions. But yes, something that's dedicated to a certain space, like say your living area. So that's the first question to ask yourself. And the second thing is, buy the most efficient heater you can afford, because it's a 10 plus, often a 20 plus year investment, and every year it will be saving you money if it's more efficient, if you buy the more efficient model over the less efficient model. Now, yeah, as I say, there are two different types of heating approaches. The first is space heating or room heating. It's the same thing. It just means dedicating a heater to a certain space. And the other approach is a central heating. So here, of course, we've got a diagram of central heating. This is an example of a space or a room heater mounted into a wall. So that's a gas wall-mounted space heater. Space or room heating is always more efficient simply because you'll be heating a much smaller space. If you heat just your living area versus heating the entire house, you're probably heating 30 or 40% of the total volume of the house, and that means your heater has to work a lot less hard and thus uses a lot less energy. I also want to mention that there's a lot of confusion around electrical heaters, but really they break down into only two types, and I want to get this one clear. So the first type of electrical heater is a reverse cycle air conditioner, also called an RCAC. If you ever see that acronym, that's what it means. Now, reverse cycle air conditioners use electricity to draw heat from the air around them, and they are highly efficient at moderate temperatures. From 5 to 35 degrees, they work really, really, really well. So during the day, if you're thinking, should I put my central heating on or use the reverse cycle air conditioner, use the reverse cycle air conditioner. It'll be more efficient because during the day, it's rarely going to get below 10 degrees in Canberra, sometimes 7 or 8, but still, the RCAC will be very efficient. Below 5 degrees, they become less efficient. Now, the more recent models are quite good. The last, say, 5 years, they've improved the refrigerant gases and the heat pump designs, and a lot of the manufacturers, the big manufacturers, you know, Mitsubishi and Panasonic and Daikin and so on, they all claim that their heat pumps will work pretty well down to -5 these days. Some of them claim a lot lower, but I haven't actually seen that. So that's reverse cycle air conditioners. Basically, for every unit of heat you put into one of them, if it's operating in these moderate temperatures, you'll get 3 to 4 units of heat coming out of it. So it's highly efficient. And even at lower temperatures, you'll probably get over 2 units of heat for every unit of electricity you put into it. So it's still more efficient than something like an electric resistance heater. Now, electric resistance heaters are things like panel heaters, column heaters, radiant bar heaters. You might have seen those heaters with that turn orange or red and send the radiant heat at you, or something like a fan heater, little blow fan heaters. They're all the same, pretty much. And you put in 1 unit of electricity into them, you get just under 1 unit of heat out of them. So there are all shapes and sizes of these things, but don't be fooled by it, they're all the same. 1 in, 1 out. So I'll just run through space heaters from most to least efficient. The most efficient space heater is an efficient fluid gas space heater, like I showed you one of these, a new one of these. They're very efficient these days. They're fluid, which means the bad gases go out, not into the room that you're in. Don't put in unfluid gas heaters. They're dangerous. They put out carbon monoxide, and that can actually kill you if you inhale enough of it. They also put out nitrous oxides, which trigger asthma. So an efficient fluid gas space heater is a great alternative if you just want to heat your living room, kitchen, etc. Or you could go for a new reverse cycle air conditioner. As I say, buying from a good brand, that'll be pretty effective these days. The next most efficient would be an older reverse cycle air conditioner, but if you find that you have a reverse cycle air conditioner and it doesn't put out any heat in winter when it's really cold, then it's probably just telling you that it needs to be replaced. I often find with models that are 8, 10, 12, 15 years old that they don't work very well at low temperatures. It's just their design, they're getting a bit old, they have an old refrigerant gas in there, might be time for replacement. Third, I put electric resistance or radiant heaters. That's things like column heaters and panel heaters and radiant heaters. The least efficient heater out there is an electric resistance fan heater. Those little blow fan heaters, that's the least. It's not much less efficient than these, but they are. I would only use something like a fan heater in very short bursts. If you've got cold hands or cold feet, you want to warm them up for 5 minutes, then great. Or if you want to warm up a bathroom for 5, well, I don't know about putting them in bathrooms actually. I'll take that one back. But yeah, so that's room heating. Now, central heating. The most efficient central heating out there is what we call gas hydronic. It's what we have in schools and hospitals, places like that. Typically looks like this. There's radiators around the house. There's pipes going under the house. There's a gas boiler somewhere. Heats up the water. The water comes to this thing. It radiates heat and it also heats the air around it. They're a little more expensive than ducted units, but they're extremely efficient. Firstly, you can fully zone them. That means you can if you want, just turn them on in the rooms you're using. So that can be far more efficient. You could just say your child is in the bedroom and you're in the living room. You could just turn the radiators on in that bedroom and the living room, and you're just heating those spaces rather than heating the whole house. And there's very low losses on the way to the radiator because the pipe is it's about that size. The second choice for central heating would be either a gas ducted heating system or a new reverse cycle heating system, but you want it to be zoned. Always pay for the zoning. What zoning is Okay, let's say the bedrooms and everything else is down there and our living areas is down there, and here's our central duct. It's simply a valve in the central duct that allows you to close off parts of the bedroom areas and so on that you don't necessarily want to heat. So that means you don't have to heat those spaces. The heater works a lot less. Zoning's $300 to $600 depending on the setup. It's always worth buying. It'll pay itself off in the first couple of years at the very outside. So if you're buying a new heater and it's central, always go for the zoning as well. Next would be an unzoned gas ducted or reverse cycle air conditioner. That's what most people in Canberra have, and you get the big bills because any time you turn it on, you're heating the whole house. And finally, I went 1, 2, 3, 10 because in-slab electrical resistance heating will generate massive bills. I've seen up to $5,000 a quarter. The reason is you're pumping energy through an electric wire into concrete, which takes a hell of a lot of energy to move up by even 1 degree, and then you have to leave it on for 5 to 6 months. So if you're building a house, try and avoid that. It's super expensive to run. I should also mention at this point that there is in-slab hydronic heating. So hydronic hydro water. You can get this, but not actually in radiators running through the slab. And that can be pretty good too, but you want to be able to zone that. So you want to be able to turn on and turn off parts of the house that you're not necessarily using. Other types of heaters include slow combustion wood stoves. If you want to talk about them, come and have a chat afterwards. And solar convection heaters. Those are things that take solar energy, warm the air, and pump it into the living room. Now these only work during the day. You can make one for yourself. I wouldn't be paying thousands of dollars for one though, because it's only working during the day, and mostly we want to use our heaters at night. Now let's get on to behaviour. These are things that you can take home tonight and start applying right now. The way you use your heater greatly affects how much energy it uses. And there are 3 variables that will affect your energy bill: the time the heater is on, the space it's trying to heat, and the thermostat setting. Time, space, thermostat setting. If you want some dinner party conversation, there you go. Bring those up and talk about them. Time, space, and thermostat setting. So, minimising the space you heat will minimise your bill. That's why I've already talked about zoning. Zoning is really important. If you can install it, do install it. If you don't have zoning, you can close up to 1/3 of your central heating vents without risking the heater. What you do if you close too many vents is you put a back pressure on the fan motor in the heater and you can blow the fan motor. So you can close up to 1/3 of your vents. That's a heating mechanic trick that I've heard from many guys. And finally, look, let's say you work from home and you're in the study and you're working. Rather than putting your central heater on, in that sort of situation, I'd use a heater just dedicated to that room. I'd probably get a small new reverse cycle air conditioner, mount it into the wall and just heat that tiny space, and it will use much less energy than heating your whole house all day. So that's minimising the space you heat. Minimise the time the heater is running. Now there's a myth going around that you should leave your heater on 24 hours a day on low and it'll save you energy. It's absolute garbage. You'll have 3 or 4 times the bill if you do that than if you just use your heater when you're home. I would not run heaters if you're not home during the day, and I wouldn't run them overnight either. What you want to do instead is use timers. So let's say you get up at 6:30. What I would do is time your heater to come on at 6 o'clock or 6:15. Experiment to minimise the time before you get up. Have it running for about an hour, because what you actually do in the morning is you get up, you get in the shower, you warm yourself up, you put on warm clothes, then you eat, you're active, etc. You don't actually need to heat all the way up to when you leave the house. You just need to sort of take the chill off the house and then have the timer turning it off and coming back on just before you get home. Once again, let's say you get home at 5:30, have the heater coming on at 5 or 5:15. The reason to do this is that 1 hour a day of heating will add up over the season, over the cold months, to 150 or more hours worth of heating. Now that's just saving 1 hour per day. So that will really show up on your bill. If you're currently using your heater 24 hours a day and you go back to using it, say, 6 hours a day, you'll notice a massive difference on your bill. And finally, minimise your thermostat setting. So in heat, we recommended 17 to 20, but what I'm talking about is find the lowest possible comfortable temperature for you and stick the heater on that. For every degree you increase the thermostat, you'll add up to 10% to your bill. Typically 7 or 8% to your bill per degree. So if you can put it on 18 rather than 21, you'll notice the difference on your bill. You really will. The other thing to do is think about your behaviours. You know, wear appropriate clothing. I have actually come across people who put a t-shirt and shorts on, the thermostat on 27, and then complain about having a big bill. Well, you know, put a jumper on, put some tracky dacks on, turn the thermostat down to 20, and you'll have a much smaller bill, but you'll be just as comfortable. Things like doonas and blankets, heated throw rugs, hot water bottles, heated grain bags, all of these things are very cheap heating. So if you want to, especially if you're settling down to read a book or watch TV at night, throw a doona over yourself. That's what I do, and that'll keep you very warm. And once you've done this stuff, experiment with your thermostat as well. See what the lowest temperature that you can get it on that you'll be comfortable at is. Okay, and just before we finish this section, I'll tell you a bit about cooling and hot water heating. With cooling, it's really, really simple. Fans you can use as much as you like. A pedestal or a desk fan uses 40 or 50 watts on its maximum setting. You can run that for 24 hours a day for about 20 cents. So use fans as much as you like in summer. They hardly use any energy. If you've got central evaporative cooling, I wouldn't be using that on 25-degree days, but when it gets a bit warm, yes, you can use your evaporative cooling. It's quite efficient in terms of central cooling for a house. If you have air conditioning, try to use it as sparingly as possible because it will use by far the most energy. Try and avoid using air conditioning if you can. And if you do those things that I talked about in the first bit, shading your windows properly, insulating properly, sealing your gaps and cracks, you'll find that you won't need to use air conditioning on the vast majority of summer days in Canberra. And finally, hot water heating. Hot water heating, this is assuming a storage tank, but it'll account for roughly 20% of your annual total energy bill, less if you use heaters other than storage tanks. So very simply, I'll break it down for you. The most efficient type of hot water heating is solar, whether it's gas or electrically boosted. If you've got access to gas, I would always put a gas booster in because it's something you can just set and forget. You don't have to mess around with it, whereas electrical takes a little bit more management. The next most efficient is an instant. They're the boxes about that big that are bolted onto the side of your house. In Canberra, they're mostly gas instants. Electrical instant heaters do actually exist if you don't have access to gas. They're very popular in Perth, apparently. I haven't seen too many in Canberra, though. And then with storage tanks, unfortunately, your electric storage tank or gas storage tank, think of it as a kettle set on 60 degrees 24 hours a day, because that's really what it is. It's heating depending on the size of it, it's heating all that water to 60 degrees, and make sure your storage tank is set to 60 degrees. Any warmer and you're just wasting energy, but legally you've got to set it to 60 degrees due to Legionella risk. So if you're replacing a tank, go for an instant or a solar. Certainly instants are a good choice. Solar's an even better choice if you can afford it. I have another quick question and answer session. Any questions? Yes, sir.
Yeah, so what you're saying before about the heating.
Yeah.
I've got a newborn at home. So we've been leaving, we've got central heating, so we've been leaving on about 16 degrees and leaving that on all night. So would we be better than to say maybe move a column heater into that room and leave that on all night?
It's a good question. Yeah, what you want to do is make sure you've got good window coverings in that room so that you're keeping the heat in and the insulation and ceiling, obviously. And then, yeah, you'd probably be better put a thermometer where the baby sleeps.
Yep.
Get the column heater and take that in there, because column heaters generally don't have thermometers. They have 1, 2, 3, 4, 5 settings or 1 to 7 settings. Experiment with the setting so that where the baby sleeps is, say, 16 degrees, as you said. It might take a bit of experimentation. But yeah, look, you will use a bit more electricity because column heaters use a lot of electricity, but you won't be heating the whole house. I can't guarantee you. It depends how well insulated, what your window coverings are like. It depends on a lot of variables as to whether the heater running overnight will use more gas than electricity, but I would, because of the space you're heating, I would say you would probably be ahead, probably well ahead putting a column heater.
Right, okay. And just
or you could, the other thing is you could go with a reverse cycle air conditioner. But that's more of an upfront cost, you know. Yeah, indeed. Yeah. Anyone else want to ask a question? Yes, sir.
Well, coming to that hydronic heating, I'm going with insulate hydronic.
Insulate hydronic,
yes. And I'm thinking of combining it with a combi boiler for hot water system. Would it be efficient?
Sorry, with what type of hot water system?
Combination boiler. Bosch, they give 37 kilowatt combination boiler. So you use the same boiler
I see.
to heat
for the slab
insulate heating
hot
and the hot water
right.
system. Would it be efficient, or going two different systems, one for the...
I would say having a single system would probably be more efficient than having two systems. The other thing, well, if you want to be super efficient, what you could do is put a couple of solar hot water heaters on your roof and have the hot water from them running through your in-slab hydronic all day, heating your slab up to 30 plus degrees, and then that'll slowly cool overnight, releasing heat to the house, and you've got heating for free there. But yeah, why don't we talk about this afterwards, if you can? Yeah, excellent. Would anyone, one more maybe? No? Is everyone happy? Yes, sir.
We've got all our windows are aluminium windows frames, and we've been told that the best solution for us is to have like two sets of windows, a double.
Oh, I see, a second, yeah, double. That's called secondary glazing. Yes, secondary glazing. That'll do a bit for you. It's not as effective as double glazing, but it will improve things. And it will certainly, the other advantage is that if the original window is at all leaky, then that's going to stop any air leaks. So yeah, don't expect it to be quite as good as double glazing, but it should help, yes. Okay, let's push on through to the last part of the presentation, and that is, let's just call it everything else. So remember, heating 60% or more, hot water heating 20% or more of your energy consumption. So we've already talked about 80% or more of your energy consumption for a typical household in Canberra. So this is the final 20%. You can make savings here. Don't think that you can't, but the savings will be much smaller. So with lighting, it's pretty simple. Any incandescent globes, those are your old school round globes, or your halogen globes, you want to replace them with CFL. That just stands for compact fluorescent. Those are the squiggly ones. Now LEDs might seem expensive. They're expensive up front. You know, the fittings, the globes can be $12 or $15. The fittings can be anywhere from $20 to $100 depending on quality. But the thing is, they last up to 50 times as long as an incandescent globe, and they use 90% less energy. With compact fluoros, you're talking 75% less energy, and you're talking up to 10 times as long in lifespan. So even though you're paying a bit more up front, you save a lot of money over time, and you also save the hassle of having to change them and replace them all the time. So lighting's pretty simple. And if you want more information on lighting, go to a lighting shop and have a talk with a professional. They're really good. Some simple things with clothes washing. If you wear a t-shirt for an hour and then take it off and put something else on, it's probably not dirty, so you don't have to wash it, I guess. What I do is just examine your behaviours. You know, am I washing things that don't need washing, etc. Always wash with a full load, because the washer will use, well, most washers will use the same amount of energy and water regardless of how much clothing is in there, or towels and sheets and so on. Try to avoid using clothes dryers. They use a lot of power. And if it's raining, try drying on a clothes horse inside instead. If you do have a clothes dryer, just use it for emergencies. It can be good for emergencies if we get 4 or 5 rainy days in a row, but otherwise try and avoid it. With cooking, there's not many ways to save energy when cooking. A lid on a saucepan saves about 1/3 of the energy versus no lid up to boiling. A fan-forced oven is more efficient, although of course you wouldn't use it with some things, like you wouldn't fan-force a roast the whole time, or you'll end up with a very dried-out roast. You might put the fan-forcing on at the end to dry out the skin though. And microwaves are also quite efficient. With dishwashing, only use the dishwasher when full, because once again it'll use the same energy and water if there's one plate in it versus being full. And when washing with by hand, try to use as little water as possible. That leads us on to standby power. So standby power is the power that appliances use when you're not using them. So anything with a light, a clock, a display, a remote control, or if it's warm to the touch, those things definitely have standby power. There are some things though that you can't feel standby power with. They have a transformer in them and you can't actually feel the warmth, you can't see the light or the display. Standby power can be up to, some say 10%, but I typically see 3 to 8% of your household electricity bills. Now, how do you get rid of standby power? It's as simple as this. Let's say we've got an appliance plugged into this over here. Flick it off, and no power can go through it. So if you want to save your standby power, whenever you're not using an appliance, simply flick it off at the wall and it won't be using any power. Most standby power occurs at clusters of appliances. So entertainment equipment, often you've got 5 or 6 different devices all plugged into a power board there, and often they're all using standby power. It could be computer equipment as well, often the same thing, 5 or 6 appliances all sitting there, all using standby power. So the way to get around this is to use things like, these are called wireless remote switches. So with something like this, let's say you've got your power board with your 5 appliances on it, you plug that into one of these switches, plug the switch into the wall, and then you've got a remote control here that you can just press off and it kills the switch. That stops you from having to, dive around behind units and so on and hurting yourself and making it a hassle. You could also use something like this. This is a power board with individual switches on it. This is what I use for my computer equipment. I have one with 6 individual switches. I have it stuck to my desk. I have little labels next to each switch telling me what everything is. And then I only turn on the switches for the appliances that I'm using. So generally I only use the computer and the monitor, and so those are the only 2 things I switch on. When I need the printer, I switch that on. When I need the light in the corner, I switch that on. And this is a master-slave power board. You plug the master appliance into here, and then the slave appliances turn off whenever the master appliance is turned off. So these are some approaches to saving your standby power, but just remember, it's as easy as flicking things off at the switch. And really, you've just got to reorganize yourself to do it. And if you keep forgetting, I used post-it notes on things. Turn it off. That's all I wrote on my post-it note. And then within a week, I was doing it. It was a habit. It's just a matter of changing little habits. And then you're saving standby power. I will also mention things like modems, routers. If you're not home and you're not actually downloading anything, you're not using the internet and you don't have Skype phone, turn them off when you're not using them. There's no real reason to have them on. Extra phones are another one I see a lot of. Sometimes you see 5 phones scattered around a house, but only 2 of them are used. Turn the other 3 off. Things like that. And that also goes with things like second fridges. Let's say you've got a fridge in your garage and you've got a 6-pack of beer in the fridge. Move the 6-pack to your main fridge and turn that fridge off. It's great to have a second fridge for emergencies, but if you're not really using it, then turn it off and you'll save yourself quite a bit of power. Refrigeration is often the 3rd biggest energy user in a house. And finally, pool pumps. Pool pumps use a lot of power, and you'll be told to leave them on 12 hours a day year-round. But you'll be told that by people who don't have to pay your electricity bill. They use a lot of power. So what I would do is in winter, I'd be only using them 1 or 2 hours a day. Some people put it on for 3 hours every 3 days because the algal growth is much slower in winter when it's cold. In summer, you might need to use it 4 to 6 hours. You have to experiment. But what I would do is experiment to minimise the time where you get a clean pool, but you're also minimising your pool pump use. And that is my presentation. Thank you for listening. I'll now take any questions, and I'll also hang around afterwards to answer individual questions for anyone who needs to ask them. Thanks very much for coming along. We really appreciate it. All the best.